Morning, guys. Thought I'd make a little video for you. Looked at some of the problems in section 5, and I thought, oh, Lord, quadratic inequalities. So I'm going to start with get my pen working here. Come on, little fella. Yay. I'm going to start with a factored form. X minus 2 times x plus 4, something like that, greater than 0. And just remind you that if I have this as an equality, then there are two solutions. X minus 2 is 0, or x plus 4 is 0, right? And that's a logical deduction that comes from thinking about the fact that if you multiply two things together and it makes 0, one of them has to be 0. Okay. This is more complicated because I just said that I had to be greater than 0. Right? Obviously, if it's greater than or equal to, then this is part of the solution. And that's an important insight because it helps me think about the fact that the number line will be split into 3 segments, basically. I'd have a segment over here, and a segment between -4 and 2, and a segment over here. Right? So in terms of interval notation, right, that's -infinity to -4. That's one interval. There's -4 to 2. That's another interval. And there's 2 to infinity. And that's backed up by the graphical representation of this, which we can look at in Desmos, or I can just do quickly here because I have pretty good graphing skills. Right? Basically, two things went into my graphical creation, which is I knew that the x-intercepts would be -2, 0, and -4, 0. And I also knew it would be facing up because if I multiply this out, it would be x squared, blah, 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 blah. And since it's a positive a value, a coefficient in front of x squared, it's facing up. So this is my picture. Right, so this -infinity to -4, -4 to 2, 2 to infinity breaks the graph up into 3 distinct regions. This one, this one, and this one. Okay. And again, I'm thinking in terms of x, but I'm looking at what the value is in terms of y. So when I want the result of this times this to be greater than 0, I'm talking about these branches up here. This branch is where the result is greater than 0, and this branch is where it's greater than 0. The only place where it's less than 0 is in the middle from here to here. Okay? So I visually answered my question, which is I can see that what I want is this one and this one. Now, just a quick check. I mean, I don't have to just use my visual intuition. I can use numbers to kind of crunch this out. I could check x equals -10. Well, let's look. -10 minus 2 and -10 plus 4 is greater than 0. That's true. I didn't even have to multiply because this is a negative and this is going to be a negative. A negative times a negative is positive. What about x equals 5? Okay, well then 5 minus 2, that's a positive number, and 5 plus 9, that's a positive number. Multiply them together, you're going to get something greater than 0. That's true. Okay? If I wanted to go one step further, I could check a number in the middle and show that in that case, I get something that's negative and something that's positive, and when you multiply them together, you get a negative result. Okay, so that's kind of the starting point, is just understanding there's a graphical analysis, there's kind of a number analysis. What if I get something much more complicated? I saw this problem in the homework section. So, first of all, whew, that looks kind of intimidating. You can always mentally or actually physically change this to an equal sign if that makes you feel less intimidated. The only thing wrong with physically changing it to an equal sign is you got to remember to change it back, because it's not an equal sign, it's an inequality. But anyways, my approach should be the same as if that were an equal, which is, this is quadratic, get everything over to one side. So 5x squared minus 24x minus 5 is greater than or equal to 0. It seems kind of difficult to factor, but I know that it does, because they wouldn't give me a problem that didn't factor. That would be cruel of them. I think I need the 5x and the 5 to multiply each other. So I'm going to make this 1 and 1x. So and then I have 25x and 1x. To make negative 24, I need that to be negative and this to be positive. Okay, just to check, 5x plus 1, 1x minus 5. I got my 5x squared. I got my negative 25x. I got my 1x minus 25x plus 1x minus 5. Okay, I'm in good shape. So now I'm back to where I started, which is I've got two things and I need to figure out the interval that works. Now, again, I would solve this separately. This should be part of my approach to dealing with quadratics that are factored, right? Writing out the answer. This one's easy to see is 5. This one requires just a little bit of algebra. 5x equals -1, so x equals -1/5. So I got double negative there. Got a little excited. And again, number line helps me kind of break it apart. Let's put 0 on here. This is -1/5. This is 5. So bingo, bango, bongo. Negative infinity to -1/5. That's one interval. -1/5 to 5. That's another interval. And 5 to infinity is another interval. Again, given that this is facing upwards, I already have an idea that it's probably this one and this one that are the solutions. Can't always say that. I mean, if it's flipped upside down, or if I wanted something that's less than 0, then I would be looking other places. But again, I'm kind of relying on my graphical knowledge, the fact that this is an upward facing parabola and I want something that's greater than 0, greater than or equal to, that's going to have an impact at the end. I'm just going to pick -5 for this interval. I'm going to pick 10 for this interval. I'll plug it in. If I want to be thorough, I should plug it in at the top, not over here, because what if I've made a mistake in how I did the manipulation? So let me show you what that looks like. I'm going to erase this. So if I check x equals -5, 5 times 25 minus 1 is greater than -120. That's a pretty safe bet. 5 times 24 is greater than -120. Check, that's true. Okay, now what about this one? 5 times 99 is greater than 240. A little bit harder because 240 has a higher bar to clear, but still true, because 5 times 99 is almost 500. Okay, so again, I'm just checking one number in the interval. Logically, any number is the same as any other number. That's way easier to see in the factored form, because basically, if I'm just thinking in terms of sign, I want this to be greater than or equal to 0. I need this to be positive, positive, or this to be negative, negative. And these are the critical points that break up and make the changes, right? When do I switch from positive to negative? Well, over here, it's the difference between like 5.1 and 4.9, right? 5.1 as an input makes this positive, but 4.9 would make it negative. Now, just to be clear about the answer, since this was greater than or equal to 0, if these are my two intervals, I need to remember that the -1/5 and the 5 are solutions here. So how do I fix that? I make it inclusive. and 5 to infinity. Okay. You took the midterm last week. I know that that was difficult for some of you. I hope that you've coming into this with some renewed commitment, and you're 4 weeks from the finish line. This is hard stuff. Don't get discouraged. If you need help, just reach out and let me know. You got till Sunday to do the work. I'm here for you. Hope you have a good day. I'll talk to you later.